Good morning students. Today we are going to see problems in Unit 4 Electric Charge and Electric Current. Page number 40, Problem 1. How many electrons will be there in 1 coulomb of charge? We have to find out the number of electrons in 1 coulomb. Given data, charge Q is equal to 1 coulomb. Charge of electron E is equal to 1.6 into 10 power minus 19 coulomb. The value of electron charge is given in your book in page number 39. The charge of an electron represented as E is the fundamental unit with a charge equal to 1.6 into 10 power minus 19 coulomb. That value we have to use it here. Now we have to find out the number of electrons in 1 coulomb. Formula Q is equal to Ne. From this we have to find out the number of electrons. So N is equal to Q by E. Solution N is equal to Q by E. The value of electric charge Q is equal to 1. And then the charge of electron is 1.6 into 10 power minus 19. Now this 10 power minus 19 goes to the numerator. So we have to get 10 power plus 19. Now 1 by 1.6 into 10 power 19. To remove the decimal we have to multiply with 10. So we get 1 into 10 by 1.6 into 10 into 10 power 19. Now when we multiply this we have to get 10 by 16 into 10 power 19. When we divide 10 and 16 we get 0.625 into 10 power 19. Now when we multiply 0.625 into 10 we get 6.25 into 10 power 18 electrons. So result number of electrons in 1 coulomb is equal to 6.25 into 10 power 18 electrons. Problem 2 in page number 42 in your science book. If 25 coulomb charge is determined to pass through a wire of any cross section in 50 seconds, what is the measure of current? Electric charge value is given as 25 coulomb. For that the charge flows in a wire within a time 50 seconds. We have to measure the current in that wire. So given data, charge Q is equal to 25 coulomb, time T is equal to 50 seconds. We have to find out the current. The formula to find out the current I is equal to Q by T. Solution current I is equal to Q by T. The value for Q is 25 coulomb and then the time is 50 seconds. When we divide 25 and 50 we get 1 by 2 coulomb per second. Now when we divide 1 and 2 we get 0.5 ampere. The unit coulomb per second is equal to ampere. So the current I is equal to 0.5 ampere. Now problem 3 in page number 42 in your book. The current flowing through a lamp is 0.2 ampere. If the lamp is switched on for 1 hour, what is the total electric charge that passes through the lamp? The current flows in the lamp is 0.2 ampere and then the lamp is switched for 1 hour. We have to find out the electric charge Q passes through the lamp. So given data, current I is equal to 0.2 ampere. Time T is equal to 1 hour. Now we have to convert this hour into seconds. Whenever the unit for time is given in hour, we have to convert into seconds and then we have to do the problem. So 1 into 60 seconds into 60 seconds, we have to get 3600 seconds. Now we have to find out the electric charge Q. To find out the formula I is equal to Q by 2. From this we have to find out the electric charge. So Q is equal to I into T. Solution: Q is equal to I into T. The value for current I is 0.2 ampere into 3600 seconds. When we multiply 0.2 and then 3600, we get 720 ampere seconds or coulomb. The unit ampere second and coulomb both are equal. So the result electric charge Q is equal to 720 coulomb. Now problem 4 in page number 42. The EMF of a cell is 1.5 volt. What is the energy provided by the cell to drive 0.5 coulomb of charge around the circuit? The electromotive force of a cell is given as 1.5 volt. This electromotive force produces the electric charge as 0.5 coulomb. We have to find out the electrical energy. So we have to find work done. W formula epsilon is equal to W by Q. From this we have to find out the work done. So W is equal to epsilon into Q. Solution: work done is equal to epsilon into Q is equal to 1.5 volt into 0.5 coulomb. Now when we multiply 1.5 and 0.5, we get 0.75 joules. So result: work done W is equal to 0.75 joules. Problem 5 in page number 43 in your book. A charge of 2 into 10 power 4 coulomb flows through an electric heater. The amount of electrical energy converted into thermal energy is 5 megajoules. Compute the potential difference across the ends of the heater. The electric charge is given as 2 into 10 power 4 coulomb, and then the electrical energy is converted into thermal energy, that is the work done is given as 5 megajoules. We have to find out the potential difference. So the electric charge Q is equal to 2 into 10 power 4 coulomb. Work done W is equal to 5 megajoules. So this megajoules we have to write it as 10 power 6 joules. So 5 into 10 power 6 joules. We have to find potential difference V. So the formula to find out the potential difference: V is equal to W by Q. Solution: potential difference V is equal to W by Q. The work done value is given as 5 into 10 power 6 joules, and then the electric charge Q is given as 2 into 10 power 4 coulomb. When we divide 5 and 2, we get 2.5, and then when we cancel 10 power 6 and 10 power 4, we get 10 power 2 volt. Now when we multiply 2.5 and 10 power 2, we get 250 volt. So the result potential difference is equal to 250 volt. Now 7th Roman exercise problems in page number 50. Question number 1. Rubbing a comb on hair makes the comb get minus 0.4 coulomb. We have two questions. The first one, we have to find out the material, which one lost electron and which one gained it, and then find how many electrons are transferred in this process. That is, when we rub the comb with your hair, the comb get minus 0.5 coulomb. Now in between the comb and hair, which one lost electron and which one gained electron, we have to find out. That is the first question. And then second question, we have to find out the number of electrons transferred between comb and hair. So the first one answer: comb gained electrons and then dry hair loses electrons. And then second one, given data, charge Q is equal to 0.4 coulomb. The charge of electron E is equal to 1.6 into 10 power 19 coulomb. To find number of electrons, N. Formula to find out number of electrons, we know the formula: charge Q is equal to Ne. From this we have to find out the number of electrons. So N is equal to Q by E. Solution: the number of electrons N is equal to Q by E. The value for Q is 0.4, and then the value for electron is 1.6 into 10 power minus 19. Now we have to bring this 10 power minus 19 to the numerator. We get 10 power 19 plus 19, and then we have to remove the decimal for both numerator and denominator. So we have to multiply with 10. So 0.4 into 10 by 1.6 into 10. Now when we remove the decimal, we get 4 by 16 into 10 power 19. Now when we divide 4 and 16, we get 1 by 4 into 10 power 19. Now when we divide 1 and 4, we get 0.25 into 10 power 19 electrons. So then the result we get number of electrons is equal to 0.25 into 10 power 19 electrons. Second problem, calculate the amount of charge that would flow in 2 hours through an element of an electric bulb drawing a current of 2.5 ampere. We have to find out the electric charge. The time is given as 2 hours and then the current value is given as 2.5 ampere. So the current I is equal to 2.5 ampere. Time T is equal to 2 hours. I already told you, whenever the unit is given in hours, we have to convert it into seconds. So 2 into 60 seconds into 60 seconds. So 2 into 3600 seconds. When we multiply these two, we get 7200 seconds. We have to find out the amount of charge Q. The formula I is equal to Q by T. From this we have to find out the charge. So Q is equal to I into T. Solution, amount of charge Q is equal to I into T is equal to 2.5 ampere into 7200 seconds. When we multiply 2.5 and 7200, we get 18,000 coulombs. So the result, amount of charge Q is equal to 18,000 coulombs. Thank you, students.